So I've been working on converting the open source MakeHuman 3D character generator from Blender into Godot, and I figured out how to import all of the shape keys from the Blender config files in the plugin folder instead of having to manually import them from Blender by hand. So as you can see, I have all of the baby, child, young adult, and old adult shape keys for each race and gender. And those were imported from the add-on config folder. So this is in home, config, Blender, scripts, add-ons, data targets. And as you can see, there's shape key folders in all of these. But for now, I just have all of the base macro keys imported. So I'll show you how I achieve this, and I'll also put a link to the source code in the description if you want to download that. So I'll go ahead and make a new human from the default settings in Blender, and under model phenotype you can see the macro details. So we also have the shape keys, which correspond to the gender, age, weight, and height variables. And as you can see, changing these shape keys affects the character model. So if you notice, these are corresponding to the young and average weight and height macros. So if I change the age to 1, you can see that the shape keys are replaced with the old naming convention. So, and if I were to turn the muscle up, these would change as well. So basically every combination of these macros has its own shape key within ranges, and then there's some mutually exclusive ones as well that increment up and down. So like on the legs, we have the vertical scaling, and the increase shape key is replaced with the decrease. So basically I would have to sit here and export a bunch of different models to get all of the different combinations from Blender. And instead of sitting here and exporting these individually, which would be very tedious, or making a macro or teaching AI to do it, I went to the Blender plugin folder. For me, that's in home config, Blender 3.6, and then in the scripts, add-ons, MPFB, and data, there is a targets folder. So here are all of the target shape key data. As you can see, there's quite a few. And then they have corresponding files in the proportions and height as well. So, and in each one of these is just a file with the vertex index and then 3 values for the position on the X, Y, and Z. So I decided to just get the data straight from here instead of exporting it through Blender. But I will still need the base model at least, so I'll reset this. So I have the default mesh now with the shape keys, and I need to delete the hide helpers modifier so the shape keys are accessible in Godot. And you can delete the helper geometries under operations base mesh delete helpers, but this will re-index the vertices in the base model and they won't map to the indexes in the target file. So instead I'll make a transparent, semi-transparent texture for the model so you can see the features. So to make the texture, click on the red globe for material and make a new material and click on the yellow circle next to base color and click image texture, then make a new image. You can rename it like so. Then under texture paint, you can see it's in all black, and you'll want to, under the data tab, find the body vertex group and then go to edit mode, and you'll want to select all the vertices with A and then deselect the body vertex groups so just the helper is selected. Then go back to the texture paint mode and with paint mask enabled, then we'll fill the helper geometry with white. Now now under the image menu, you can save as, and I'll put this in a new Godot project. So this will make a PNG image externally, and now I can save the human model in the project as well as a blend file. Now I don't know how to make transparent textures in Blender, so I'll open the hide helpers PNG with gimp instead and ignore the PNG offset, otherwise the texture will not line up. Then under colors, click color to alpha with white selected by default to hide the helper geometry, and then under colors use invert to make the rest of the texture white so Godot can change the base color. Then under file, overwrite hide helpers PNG to resave it, and you can discard changes. And once the assets are done loading in Godot, you can make a new 3D scene and drag the human.blend file directly into the tree. Right click and select Make Local. Then drag the mesh under the root node, like so. And I'll reset the position. Then under Surface Material Override, I'll drag the Hide Helpers PNG. This will set the texture of the albedo image. Under Transparency, set the transparency to alpha. So you can see that got rid of the helpers, but there's still some. You can see the arms and the face are inverted with the body. So under Depth Draw, use Always. And now you can see the face and arms are rendered correctly. Then under Color, you can change the albedo to change the color of the actual model to whatever you would like. And the blend shapes are still available in the inspector for the mesh instance node. So, as you can see, all of the shape keys still work, and you can see the underlying features, but the helper geometries are still there. So the indexes, the vertex indexes, and the data files still match up, should match up with the model in Godot. Now I want to add all of the other shape keys from the targets folder in the GoMakeHuman.plugin. So as you can see, there's quite a few. I'll need to extract each one. So this is a gzip, and the target file is a text file, which I'll need to open. So there is an open compressed function in the file access class, but it says this didn't work because it can only read files that were saved by Godot, not third-party compression formats. So even though gzip is one of the listed compression modes, and I did go to the workaround and I tried to store the header manually, but that didn't work for me. So for now, I'll just copy them manually from here. I'm not going to move all of them right now, but I made a shape key data in the folder in the Godot project, and then you can select multiple files and use extract here if you have gzip installed to extract them all. So I'll just move over a couple manually for example to get it working, and then I'll probably write a Python script to move them all over programmatically and extract them, which I'll include with the project at some point. So now I want to add all of the additional shape keys, and you can't actually add blend shapes to an existing array mesh. You can add the name, but it needs to be called before the surface is added. So when you add a surface from arrays, it takes the primitive type, which is triangles or lines, and then the array of vertices and faces, and then it takes an optional blend shapes array. So I'll need to recreate the mesh first and add the blend shapes when I actually create the mesh. So I'll attach a new script and make it built in to the import shapekey scene. So first, I'll make a new variable for the mesh arrays, which will be the import mesh variable, and then I'll use surface get arrays from the mesh class. On the first surface at index 0, so the 3D model only has one surface material. As you can see, it only has one surface. If there were more, you would have to duplicate this for each surface. Then I'll make a new mesh variable, which will be a new ArrayMesh. And then I'll add surface from arrays on the new mesh. This will use triangles, which is normally what they use, and then I'll pass in the mesh arrays from the original model, and then you can use resource saver .save, pass in the new mesh resource, and set the save path. I use res, which will save it in the project, but that won't work once it's compiled. You'll have to use the user, but since this is just for development, you can use the res folder. So generate mesh and then human.resource. So this will save the mesh as a new file. And then if you run the local scene, so I didn't put any output, but once it's finished, you can close it. And now it's generated the human resource from the 3D model. So it has the default skin, so you can still see the helpers. And you can save the surface material of the human model so that you can then use the material on the new model as well. So you can see they look the same. The export mesh doesn't have any of the blend keys available because I haven't added them yet. So I'll do that next. So there's two kinds of blend shapes. There's the normalized and relative. So relative is additive, and normalized is the absolute value of the vertice positions. So by default, this generates the mesh as relative, but the original is normalized. So if I look in the target files, I can tell that these are relative because there's a bunch of zeros and very small numbers. So this will just add or subtract 0.00300 from the 51st index. So you can see it just shifts them over slightly. This is for the nose, so we don't expect it to move that far. And only the shape keys that are affected are listed. So this one only has around 500, whereas the shape keys that affect the entire body will have all of the vertices listed, which is over 19,000. Now when you go to add the blend shape arrays in the add surface from arrays function on ArrayMesh, each blend shape needs its own set of arrays in the format of the original arrays. So this will be of size array max, but most of the arrays will be set to null, except for the vertex and potentially the normal and tangent. So I'll need to make an array of blend shape arrays after I make the new mesh and before I call the add surface from arrays function. So I'll make a new array for the blend arrays, and then I'll make a array for the actual shape keys, and then at the end you'll append all of the shape arrays to the blend arrays. So it'll be an array of arrays. Now I want to resize the test shape arrays to the mesh array max, which I think is like 13. And then I'll want to set the vertex index to a new set the test shape vertex to a new vector 3 array. And then I want to resize this so it's the same size as the import mesh vertex array. Otherwise it won't work. So get the array vertex index from the import arrays and get the size. And then so I'll resize the test shape vertex array, and for now I just want to show you the difference between the relative and normalized blend keys. So I'll fill the vertex array with vector 3s of 1, 0, 0, and it's already set to relative by default, but I can just set the new mesh set blend type blend shape mode. There we go. And set it to relative. And I'll also need to add the blend shape name to the mesh before you call the add surface from arrays. So add blend shape test shape, and now I should be able to add the blend arrays to the add surface from arrays to create the new key. So it did throw an error on the export mesh. It says the blend weights.size is out of bounds. This is because the original model has the array normals and tangent array set, but the blend shapes does not. So for now, I'll just set those to null. So in mesh arrays, I'll set the normal array to null and the tangent array to null. And now if I run it again, it shouldn't have any errors. So you can see the model is there, but the shading is much different because we removed the normals. So now it's just using default lighting. And if I reset the surface material override, you can see the body doesn't have any shading on it at all. So that's what happens from the normals. Now you can see the blend shapes key was generated, and if I turn it all the way up, it moves the entire model over to the right and left, because all of the shape keys were set to the same thing, so it just translates the entire model over, basically. And now if I change the blend shape mode to normalized instead of relative, and rerun it, now you can see that it shrinks down all of the points to the absolute position of 1, 0, 0. Instead of adding it to all the vertices, it's interpolating. So that's the difference between normalized and relative. And this mesh does update automatically when I regenerate it, because it is still pointing at the human resource that we're generating. So as long as you don't make this unique, it will update after you run it automatically, which is very useful. So now I want to import the shape keys from the target files that I copied from the plugin folder. So I'll need to loop over the directory using dir access and return all of the file names. So I'll copy the example function from the dir access documentation on Godot, and I'll make a new function to get target files, and so I'll make a new array of file names, and if it found a file, I'll append the path plus a slash for the delimiter and add the file name to the array, and then when it's done, return the files array. So you can return the empty array if there was an error, so that'll be fine. And now I'll rename this function, and now in the ready function, I'll get the target files first, and this is from the shapekey data. You can just drag it in, and I'll remove the slash since I'm appending it here. Then I'll call the makeMesh function. So I'll just run this to make sure it sees all of the files correctly and it doesn't throw any errors. So it found all of the target files and presumably returned the array. And this will be actually easier if I make files a dictionary instead of an array. So it will keep the order that they're added in, so the index will still be preserved. And I want to get the shape key name from the file name. So instead of, it'll just return head triangular without the .target for the dictionary index. So I'll use the getSlice function, which returns the substring between the delimiters at the given index. So I'll get the shape key name from the file name, getSlice, use a dot as the delimiter, and get the first slice at the 0 index. And then instead of appending to the files, I'll set the index to shape name equals the file path. Next, I'll make a function to process the target files, which takes the dictionary of file names. So I'll loop over the shape name index from files, and then I'll use file access. So I'll make a new variable for the target file, and then use file access to open the string path. So files at shape name, and use file access.read. Now I want to read all of the lines in the file. So here's file access, and there is a get end of file function. End of file reached. It says not to use this though, to leap through the file. Use file.getPosition is less than getLength instead. So I'll use that. Change the file name. And then I'll get the next line from the target file and just print that out for now. So now in the ready function, I'll set make a new variable for the target files, and then pass that to process shapekeys. And this should just print out the contents of the shapekey files. So it looks like it was able to open the files and get all of the data. Now, instead of printing out the line, I want to extract the index and the vertex coordinates from each line. So I'll use the string class split floats function, which takes a delimiter and a boolean. So I'll make a new variable for the float array equals line dot split floats, use a space as the delimiter. Then I'll set the shape key index equal to floats at 0 to get the first number, and then I'll make the shape key coordinates equal to a new vector 3 with floats at 1, 2, and 3 for the x, y, and z. And I also need to move the mesh arrays and new mesh variables into the header and the blend arrays so that I can access them from all the methods. This will be an onReady var because it's referencing a child node. And now for each blend shape, I can add the shape name to the mesh. Then I'll move the test shape array for each shape. And I'll rename this to new shape. And I'll want to fill it with an empty vector so the points don't move by default. And then you'll need to add the shape at the end of the while loop to the blend arrays. And now I just need to replace the vertex in the new shape at the shape key index equal to the shape key coordinates. So now if I run this, and check the export mesh, you can see the shape keys have been added. However, this should be relative. So change that back. But you can see that the shape keys are not being applied correctly. So we're just getting spikes all over. So the issue is that the keys aren't indexed to the correct point. As you can see, this should only affect the left upper leg, but it's affecting these points on the left arm and face instead. So it's only affecting a subset, which is good, but they are in the wrong location. So I made a new human in Blender, and you can see the vertex indexes if you go to Preferences and you enable the developer extras under Interface, like that. And you may have to restart your Blender, but then you change to Edit mode and click the drop down next to the two circles, the Overlay tab, and under Developer you can select Indices. So now when you select the vertexes, you can see the numbers for each vertex. So those are the indexes that it's referencing in the shapekey file. So now I'll make an indexer in Godot to compare the keys, compare the indexes. So in Godot, I'll make a new folder to locate the vertexes, and I'll make a new 3D scene and drag the human blend file into the scene. I just want the mesh, so I made it local. And then I'll add the helper material, so it's just the default human, and reset the transform. And now I'll add a CSG mesh set to sphere mesh to indicate the vertex. So I'll change the material to red, and I'll make it smaller. Now it's hard to see because it has so many of the segments outlined, So I'll turn down the radial segments and rings as well. So now it's easier to see. And I'll rename the node to red dot as well. Then attach a new script to the scene. So I'll need a new export variable for the index of type int. And I want to override the set function to set index equal to the value first, and then I'll call the update index function, and I'll need to declare that. And for now, I'll just print index updated. And now there's the index. I also need to declare this as a tool so that it will work in the editor. And now, when I update the index, I may also have to reload the scene. So now when I change the index, it prints out index updated, so I know the function is getting called. Now I need to get the vertex array, so I'll copy the mesh.getSurfaceArrays variable and rename it to vertices, and I'll call the human mesh, and we'll get the vertex array. Then in the update index, I'll get the coordinates, which equals the vertices at index, then set the red dot global position equal to coordinates. And save it. So now, when I update the index, so because it's an onReady variable, it needs to reload to call the ready function again. So now, when I change the index, you can see the orb, the red dot moves on the mesh to the corresponding index. So now I can compare these to the Blender indexes. So in Blender, if I select one of these vertices, this is 4038, and if I change it here, you can see this vertex is on the face. So, and if I select another one, this is 11135. So I can tell that the vertexes don't line up at all, and that's because when you import the Blender file, Godot uses the GLTF format exported through the Blender API. So it's not basically it reorders the vertex indexes when it imports it from Blender. So I went ahead and made the default cube for testing. So in a new Blender project, I'll delete the camera and light, then change to edit mode with the cube selected, and then enable the indexes, and I'll find the 0 vertex and go ahead and move that upwards so that I can tell it apart from all the other ones, and I'll save that in the Godot project as a blend file. Then I'll copy the vertex finder for the cube and replace the mesh. So I'll delete the human and reset the transform on the cube, make it local, and in the script I'll replace the mesh name so now if I reset the transform, and I need to reload, so now I can change the index on the cube to match with Godot. So as you can see, it moves every 3 indexes, and if I print out the vertices array, then you can see that they are duplicated. Each vertice position is duplicated 3 times within the vertices array. So there's 24 total elements here, and versus the 8 in Blender. But they do seem to be in order, so at 0 it's on the top, and I don't need to print these anymore. Then at 3, so that would be vertex 1, it's directly below it. And at 6, it moves to here, or the other side. So there is index 2. So you can see they're still in order, it's just added the duplicate vertices. So I'll make a dictionary to find all the unique vertices. First, add the dictionary variable, then loop over the vertice indexes, and I'll get the coordinates, which is vertices at V, Then I'll set the unique vertices at the coordinates. So this will be a vector 3 for the index, and set that to v, which is the index and vertices. So this will just override it if it already exists, and the unique vertices array should only have 8 elements. Then I'll make a Blender to Godot index array, and I'll want to move the unique vertice calculation into the ready function, so it's only called once. So I'll need to reload the scene to make that work, and now I want to loop over v in unique vertices and append the unique vertices at v. So this will put them in order, and basically this will be the Blender index as the array index, and then the value will be the Godot index. And in the update index function, I'll get the Godot index equal to b to g index at the index value, and then get vertices at the Godot index for the red dot coordinates, and I'll save that and reopen. So now you can see the first index is underneath the 0, and then it goes back to the second index, and the third is directly underneath that. So it looks like all the vertices are matching up now between Blender and Godot. So if I go back to the human, I know that the vertices aren't grouped in sets of 3 like the cube was, because I can see it moving as I increment the index by 1. So, but I decided to try it anyway. I know that there's about 10,000 extra coordinates in the mesh from using the get size. So I'll copy the new vertex indexing code into the human finder and save that. So now if I select a vertex in Blender, that's 1116, you can see it's in the middle of the thigh, and so I can select another one, 4154, and it moves to the middle of the stomach. So these do match up, and as far as I can tell, so that's over on the wrist. Now this wouldn't work if you had any vertices in your mesh from Blender with duplicate positions. So if you have vertices stacked on top of each other for some reason, then they're not going to match up like this. But it seems like for the Make Human model, all of the vertices have unique positions and they import in the same order. So this is how I was able to match the indexes. So I'll copy the unique vertice to the main generate mesh. I'll make a new function to index the vertices. And I'll set the vertices variable equal to the mesh arrays at the vertex. And I need the Blender to Godot index array as well here. So instead of just setting the value to the vertex index, I need to list all of the vertices so that I can apply the shape keys. Otherwise, it will just move one of them and it won't look right. So I need to check if coordinates is already in unique vertices, and if not, then set unique vertices at coordinates equal to an empty array, and then we'll append the index there. And I'll call the index vertices function in the ready function to populate the B to G index before I run the process shapekeys. Now in the process shapekeys function, I'll get the Godot index, which is the Blender to Godot index at the shapekey from the file, and then I'll loop over each index in the array and set the shapekey at the index. So I ran the script again, and now you can see that the shape keys do affect the correct location, but they seem to be very exaggerated. So it's the right shape at around 0.13, and then it becomes too exaggerated. So I compared the file to what I expected it to be from some specific shape keys, and basically you just divide the shape key coordinates by 10. And run it again. And now, once it's done, I can edit the shape keys, and you can see that they are the proper amount now. So if I compare the African male shapekey to the original, you can see that they look about the same. This one just doesn't have shading, but the model is the same. So if I change it to the Asian female, that works as well. Now I want to fix the shading, so I have been reading about generating the smooth shading from the vertex positions, but for now I'll just use the normals from the original model, and that'll be close enough. So I'll show you, instead of setting the normal and tangent in the original mesh to null, now in the new shape array, I'll set the normal and tangent equal to the import mesh, and run that. Once it's done, I can see that the export model now has the shading. However, it's kind of effeminate, so if I turn up the male slider, you can see on the original mesh with the proper normals, the chest is much smoother than in the exported model, which keeps. So, but it's good enough for now. So, but now I can navigate back to the Blender plugin config folder for MPFB and grab a whole selection of shape keys and copy them to the shapekey data. Right click to extract all if you have the gzip installed, and then sort by type so you can get rid of all of the zip folders. So now I can just run this again. So you can see that it found all of the target files, and if I go back, now all of the individual age and race sliders are available, and I didn't have to export them individually from Blender. So I don't want to move them all over by hand. I do plan to make a Python script that I'll put in the GitHub at some point to move them into the shapekey data folder, because I don't actually want to distribute all of these files if I don't have to. And there may be a database or something in the actual source code for that, so, but for now this works pretty well, and I'll put a link to the Humanizer repository in the description. So thank you for watching and have a great day.